Welcome to this topic, waves. So this is a very short and interesting topic. It's going to be delivered in a single video, and then after this we're going to take a look at other types of waves. The first one is going to be sound waves, and then we're going to end up with light waves. Then we're done with the waves. So in this video we're going to look at introduction to waves. Once we're done with introduction to waves, we're going to take a look at types of waves. Then we'll end up with just some properties of waves. So let's get started. A wave is defined as the disturbance traveling through a medium. So in any medium, if there is a disturbance and that disturbance is traveling through it, then there is a wave. Examples of waves include water wave. So think of water wave as when on still water, if you throw a stone, that's a disturbance. That disturbance is going to be traveling so that it reaches the other parts of that water. That's a disturbance traveling through a medium. Another example is sound wave. When you speak, when you make a movement with your mouth, you create a disturbance in the air. That disturbance travels till it reaches someone's ears. Light waves, electromagnetic waves, all these are types of waves. So all waves can be classified into two. So the two types of waves are transverse waves and longitudinal waves. Transverse waves and longitudinal waves. So we're going to start these two types of waves. We're going to see what makes them different and examples. So we're going to start with transverse waves. A transverse wave is just defined as the wave in which the vibrations of the particles or the disturbance are at right angle to the direction of the travel of the wave. So in any medium, if there's a disturbance, it means the particles making up that medium are going to be vibrating. So a transverse wave is one where the direction of the vibration is at right angle to the direction of the travel of the wave. So here is an example of a transverse wave. So this wave is moving from left to right. That's the direction of the wave. But the particles are vibrating up and down. So to just make sure that things are clear, if you look at this wave, it's going this direction, but the particles are moving like this. So you can say they're moving up, down, as they are going this direction. So the direction of vibration is up, down, but the waves are moving this direction, that is to the right. So the direction of the vibrations and the direction of the movement of the wave are at right angle. Such a wave is a transverse wave. A good example is water waves. So when you throw a stone on still water, then there will be ripples that are going to be created. So those movement of waters, you see them to move up, down, but they will be moving outside or away from the point where you have thrown. So the direction of the wave and the direction of the vibrations is at right angle. That's a transverse wave. So on a transverse wave, the distance from the lowest point to the highest point of the wave is called the amplitude. So the distance from here to here is called the amplitude. So you can define amplitude as the distance from the resting point of the wave to its maximum point. There's a name for this maximum point. It's called a crest. So it's the distance from the resting point to the maximum point is called amplitude. Then so we're supposed to see things here. Yeah, then another property of a transverse wave or of any wave in particular is called wavelength, which is the distance from here to here. So this is called wavelength. So what is here? The point where that is not things that we cannot see here is the point from where the wave starts to where it repeats itself. So if you look at this, it goes up, it comes back to the resting position, it goes down, it comes back to the resting position. So whatever is going to happen after this is a repetition. So again, it goes up, it comes back to the resting position, it goes down, it comes back to the resting position. So the distance from one point to where it repeats this point, or where it repeats itself, is called the wavelength. So it started from here, up, down, up, resting position, down, resting position. So he at this resting position, that's where it had started. So the distance from here to here is called the wavelength. Then the topmost point, this one is called the crest, and the bottommost point is called the trough here. The next type of wave, of course, is longitudinal wave, which is defined as a wave in which the vibrations of the particles are parallel or in the same direction to the direction of the travel of the wave. So in this one, the direction of the vibration is the same as the direction of the movement of the disturbance. A good example is this. So this is a spring. If you press this spring so that it is tied together, then you let go of it, it will be going this direction, but the particles, the wires themselves, will be vibrating like this. So the vibration is from this direction to this direction, and the wave is also moving in this direction. So you can see that the direction of the vibration is parallel to the direction of the wave. To be parallel is to be a kind of in the same direction, whether positive or negative. Yes, so you can see the direction of this particle is this side, and that's where the wave is moving. But this particle is this side, which is kind of opposite to the where the wave is moving, but still just the opposite direction, but not at right angle. So that's why we use the word parallel to mean that the direction is the same. It might be opposite, but the same. I don't know how to put this better so that you understand the use of the word parallel here. Let's say left and right. So left and right, right is one direction, left is the opposite of right. So if something is moving to the left, the other one is moving to the right, then these things are moving in parallel directions. Another case is both are moving to the right. We can use the word parallel. So parallel means moving in the same direction or moving in the opposite direction. It's different from being at right angle. So examples of longitudinal waves are waves of the spring and also sound waves. So just some terminology that I want to emphasize on. The first one is amplitude, which is defined as the maximum displacement of a particle from its resting position. The units of amplitude are meters m. The symbol is A. Then we also have wavelength, which is the minimum distance at which the wave repeats itself. So the units of wavelength is meters, and its symbol is this Greek letter called lambda. So the other terms, the other properties of the wave, we're going to use this diagram to study them. So the first one is called period, which is just the time taken for one complete vibration of a particle. So like I said, one complete vibration means from resting, up, back to resting, down, back to resting. That's one complete vibration, and this is a period. The time it takes for this to be made, it's the period of this wave. So the units of the periods, just like when we're studying pendulum, is seconds, and the symbol is t. So the kind of opposite to period, no, it's not opposite, it's frequency, which is the number of complete waves produced per second. So the number of these complete ones which are produced in 1 second is called frequency. Units of frequency is Hz, and the symbol is F. So the units of frequency is Hz, which is Hz, but you just write Hz. So there is a relationship between period and frequency. Just like in pendulum, the relationship is F is equal to 1 over T, where F is the frequency and T is the period in seconds. Finally, we're going to take a look at speed. Speed of a wave is distance traveled by the wave in 1 second. So just the distance traveled by the wave in 1 second is called speed. Units of speed is meters per second, just like before. The symbol for speed is v, and the formula that connects speed with the other two properties of a wave is this. Speed is equal to frequency times wavelength. Frequency times wavelength. That's how you get speed of a wave. So this marks the end of this topic. Hope you have enjoyed. Happy solving.